Aloha everyone, I am here to go over your non-experimental study. So this will be our second research project. And before we talk about the non-experimental design expectations, I want to ground us first in what an experimental study looks like, which will be our final study that we do in the class. Experimental studies are very unique. Not all research is in fact experimental. In fact, most scientific research utilizes non-experimental methodology. And when we're talking about experiments, specifically, that is the only method that allows us to examine cause and effect relationships. And in order to do so, it needs to be very carefully controlled. So all experiments require control and manipulation. We have to control outside factors that might potentially influence the outcome by maintaining a very carefully controlled procedure that we utilize. Sometimes we rely on scripts. We make sure that any researchers involved in data collection are very closely trained and monitored. And we do our very best to ensure there's consistency and continuity so that researcher biases aren't creeping in and influencing outcomes, and so that there aren't outside factors. For example, we can't test one group in a dark room and another group in a light room. We can't test one group after eating and one group not after eating, unless eating in fact is the treatment or the independent variable that we're exploring to see if it has an effect on an outcome, right? Otherwise, all environmental factors need to be controlled as best as possible. Participant factors are controlled by randomly assigning them to groups. So with an experiment, you have two variables, an independent variable, which is the presumed causal variable, and we manipulate that variable. We determine what that variable is and the criteria by which we're going to break up groups. So maybe we're looking at the effect of a drug. So our independent variable is the effect of a drug. And then we manipulate the variable by creating two separate groups. People who don't get the drug, who's a control group, and then people who do get the drug, which is the experimental group. And we might say they're going to get 25 milligrams of the drug. Or maybe we want to create a third group where they get 50 milligrams of the drug. And so we're going to compare, let's say it's a drug that's going to impact mood. So we're going to compare how mood differs between our non-experimental group, our control group, our 25 milligram group, and our 50 milligram group. So that's how we manipulate the independent variable. We select the treatment, we determine what different treatment groups we're going to be assigned, and we determine how much of any given treatment is that group going to be exposed to, how often they're going to be exposed to it, and as I mentioned, the different treatments involved. And then the dependent variable is the measured variable. It's what we're comparing across the groups. So we want to see if the independent variable caused, and the manipulations that we utilized, caused differences in the dependent variable across the groups that we created from the independent variable. I hope that makes sense. That is an experiment. Anything else that does not follow that very rigid process, that does not rely on random assignment, where you can literally flip a coin and decide, is a participant going to be in the control group, the 25 milligram group, or the 50 milligram group. If you can't control which group that each member is part of by random assignment, then that is not an experiment. Okay? And so effectively, when you're talking about an experimental design, you need to have, we've now recruited our sample, we randomly assign them to the control group or the experimental group. So the experimental or the treatment group receives the intervention, the 25 milligrams of the drug or the 50, and the control group does not. They allow us to see what no drug looks like, to see if the drug actually caused a change in the mood or the outcome. So anything that does not adhere to that rigid design is a non-experimental design. So effectively everything else, everything that does not involve control manipulation and random assignment is a non-experimental study. Some people might call some studies quasi-experimental, but they're still officially non-experimental. If I cannot randomly assign who is in each of the different groups, then that is a non-experimental design. So for the purposes of this class, you've studied and explored in your lecture module all different types of non-experimental studies. So we've talked about case studies, right? We've talked about just observational research and descriptive research. We have a correlational study. The correlational study examines relationships between variables rather than differences between groups. And then we are now going into a comparative study, a comparative non-experimental study, where we're going to compare some outcome between two groups. We're not going to randomly assign who's in those groups because it's not an experiment, it's a non-experiment, so those groups may come already pre-formed. For example, I can't randomly assign gender identity. That gender identity is something individuals that are associated with those individuals. And so I cannot randomly assign you to a group. Rather, you come in pre-formed groups. So I can compare mood between, men, women, and individuals with a non-binary identity. Or I can compare exercise rates between student athletes and non-student athletes, or I can compare GPA between student athletes and non-student athletes. So I can compare anything that I deem, to be interesting between two groups. Now, obviously, there needs to be a literature review and some background research to help determine what you're comparing and the two groups that you're comparing it toward are between, So in general, non-experimental research can be, descriptive in nature, where we're just gathering information and reporting out what we're observing, or when you're trying to really look at variables, specific variables of interest. That can either be correlational, where we want to see, is there a statistical relationship between the selected variables, or it can be comparative. Do different groups differ across a given variable? And so let's talk a little bit more about the difference between a correlational study and a comparative study. So when you have a correlational study, you're not creating groups. It's one single group. Every single participant does the exact same thing, answers the exact same questions, and is measured on the exact same variables and data points. So all your variables in a correlational study are measured variables. There's no independent variable. There's no grouping variable. It's all measured variables. And then what I do is I use statistics to analyze the relationship between those variables. So in this particular example, you're asking, is there a statistical relationship between temperature and ice cream sales for a local shop? And what we see is as temperature goes up, ice cream sales go up, right? So yes, there is a significant positive correlation between temperature and ice cream sales, such that higher temperatures are associated with higher volumes of ice cream sales, and lower temperatures are associated with lower volumes of ice cream sales. We're not comparing hot days to cold days. We're not comparing ice cream to coffee, right? We're merely looking at, is there a pattern of distribution or relationship between the two variables that we measured? So every one of these dots represents the intersection of where that data point scored, if I'm measuring it across a 30-day period, right? So day 1, it was 12 degrees Celsius and only $200 in sales. Day 2, it was a little over 14 degrees Celsius and just a little above $200 in sales. Day 3, it was a little bit over 15 degrees Celsius and a little over 300 in sales. See that? Notice as temperature's going up, your sales are going up. We call that a positive correlation. The tighter the dots are to one another, the more likely it is to be a statistically significant relationship. So that's a correlational study, which was one of the first things that we did. And we don't have to create groups. Now we're going to do a comparative non-experimental study. In a comparative study, you have to have at least 2 groups that are being compared to one another. So you're going to have 2 different types of variables. Unlike a correlational study where they were all measured variables, now you're going to include a grouping variable. Some people might refer to that as an independent variable, but IV is sometimes reserved specifically for experiments. But that said, a grouping variable, and then a measured variable or an outcome variable, sometimes referred to as a dependent variable. And what you're going to see, what you're going to look at as a researcher is, are there differences in this measured variable between the 2 groups? So maybe I'm going to now look at, oops, let me stop this for a second and move this image up just a little bit so we can see this better. So now maybe I'm going to look at shopping, amount of money is spent shopping in a day between men and women. So I recruit 101 men and 120 women, and we monitor their shopping for a day. And we're looking at, is there a significant difference in spending between men and women for a day of shopping in the mall? We'll say no particular occasion, just an everyday spending day. And sure enough, we see that women spend more than men on just a regular shopping trip. And so notice I have 2 different groups of participants. I have men and I have women. I didn't randomly assign to those groups. They automatically came as either a man or a woman, right? And so that being said, those groups naturally form, and then I am deciding what I want to compare between those groups. When the group is based upon something inherent about the participant that might be a demographic, we call that a participant variable. So when we take a demographic variable and we make it a point of interest in our research question, it now becomes a participant variable. But it could also be something like comparing people with short hair to people with long hair. It can be something like comparing people who live in one city to another city, comparing students who go to community college versus a university. It can be comparing psychology students to sociology students. It could be comparing students who took Psych 121 compared to students who took Math 140. It could be comparing students who like chocolate versus vanilla, right? Like it could be anything. Variables literally can be about anything. For the purposes of this class, we focus on studies that are related to psychological variables because, it's predominantly a psychology class. It could be something related to sociology, or it could be something related to communications or business as well. But most of the time, you're going to choose something related to psychology. And so when you're talking about comparative designs, where we're comparing groups, we can do a within group study or a between group study. In a within group study, it's one group, but you measure them twice. So the groups that are being compared is the scores from measurement 1 to measurement 2. Now, there's something called order effects that might take effect. For example, if I want to, let's say I want to study the difference between, let's say, a drug, like I'm going to look at, this is a group of individuals who have depression. And I'm going to compare, one group is going to go into talk therapy with no drug, and the other one is not going into talk therapy. They're just getting a therapist, right? So I'm comparing people in therapy compared to people on antidepressants. And I'm saying which one is healthier, okay? Which one has the greatest benefit and we see their depression changing? Now, for a within group design, I have the same participants. And what I'm going to do now is I'm going to say, okay, well, I'm going to measure their depression, and then I'm going to give them a drug and see if their depression change, and I'm going to measure their depression. And then I'm going to now put them in talk therapy. So give them a drug for a month and then see what their depression levels are. And then I'm going to put them in talk therapy for a month and see what their depression levels are. And I'm going to compare what their scores were at the first measurement compared to the second measurement. Now, because it could be, well, maybe there's some leftover drug in my system, and that's affecting my depression even with my therapy, then I want to do what's called counterbalancing. And half the participants, first they get the drug, then they get the therapy. And for the other half, they get the therapy first and then the drug. And what I'm looking at here is I'm looking at the change in scores. I want to see, I'm still comparing two groups of scores, right? So this group of scores was when they had the therapy, the drug, and this group of scores was when they had the therapy. And then same thing, now they get the therapy first and then the drug. So let's say this 100 people, 50 people are going to get the drug first, then the therapy, and then the other 50 are going to get the therapy first and then the drug. And then it's going to produce what we call change scores or difference scores, as you may have remembered from stats. And then what we would do is we would compare those difference scores and see if, in fact, there was a significant difference between those two treatment modalities. But every participant is getting both treatments. In this, I'm taking your 100 participants and I'm breaking them up so that 50 get the drug and 50 get the therapy. And I'm seeing which people did better. Within subjects, designs can be really powerful because I'm controlling for participant factors, right? Even in a non-experimental study, that's really valuable. However, the problem is these order effects, and I have to add an extra layer of complexity and counterbalance to try to control for those order effects. Now, mind you, I don't randomly assign who's getting drugs or who's getting your therapy. I might just, among depressed people, okay, you're on an antidepressant, okay, you're in therapy, and those groups are naturally created. So that's why this would be a non-experimental study as opposed to an experimental study where I randomly assign who gets what, right? So maybe a drug's not the best example. Maybe it could be comparing working students to non-working students and seeing what their grades are, right? Or I'm looking at one group of students who start out without a job, and then in the second semester they have a job, and now I'm comparing how that job impacted them, right? That kind of thing. Okay, so for the purposes of this next study, we are going to conduct a non-experimental univariate between groups design. So by non-experimental, we are not requiring a research question whereby you have to randomly assign participants. So you can make any comparison you want across any two groups. We are requesting that you only compare something, a selected variable, between two groups, okay? So you're going to have group A and whatever it is you're measuring, and you're going to have group B and whatever it is you're measuring. Obviously, that needs to be the same thing. And you're going to compare a single variable, which is why it's univariate, a single variable between the two groups, okay? So it's only going to be one independent variable that breaks them into groups. And so whether that's gender, class, work status, exercise, yes or no, single or married, whatever it might be, whatever you decide based on your research question. And there's going to be just one dependent variable that you're going to compare between those two groups. And it will be a between groups design because these people will be different than these people. So it's not going to be, if this is Susie, Sally, Sam, Scott, Samantha, Shelby, and Smith. Then the people in group B are they going to be Katie, Carrie, Carlos, Carlitos, Cassandra, Kalea, and Carl. Okay, so those are going to be different people in group B than you have in group A. Okay, you have to recruit at least 30 people for each of your groups, so a total of 60. So your non-experimental study, each student will propose a topic, so you'll choose your research question, and you will present that in a discussion forum. I will go through and identify which are viable studies that we can do, and then based on that, I'll put together a presentation, a slideshow, and you all, similar to how we used a mini paper management tool, will do the same, where you're going to self-select into groups, exchange your contact information just like before, and then that research group will make any final determinations on their research question. You will actually develop all the materials necessary to do your study. You will select whatever tool or scale or measure you're going to use to measure your dependent variable that you're comparing between groups. And you're going to create the Google form. So you will build it out, including an informed consent, including the measure and the questions, including your demographic questionnaire, and including your debriefing statement. And then I will review all those. Once those materials are approved, you will move into a data collection phase. All members of your group will need to participate in data collection. You need at least 60 participants, 30 in each condition. And then you will collectively analyze that data with SPSS. You will create a demographics table consistent with what you did in the mini paper, and you will create a means table which is appropriate for the type of statistical analysis you're going to do for this study. This study, you'll analyze your data using an independent measures t-test, and I'll talk about that more in just a sec. So then you will again write one single paper, a collective writing process as a research team presenting your study and your findings. Every member of the group must contribute to that collaborative writing, and they must contribute at least one empirical source for the introduction and one empirical source for your discussion. So you will be using a minimum of 10 sources for this paper. This paper inevitably will be longer, and you should do a little bit of that literature review and background research before you actually design the study. And so for those of you that may not have done Psych 121 and you've done Math 140, you may not have ever actually run a t-test with actual live data. So I'm going to encourage you to rely on one another. Do this collaboratively so you can learn from one another in the process. But you're going to run an independent measures t-test in SPSS, which is also known as a 2-sample t-test. The formula is over here. And you are, we can use this particular t-test whether it's an experimental or non-experimental study. That doesn't matter. For the purposes of our research, we're going to do a non-experimental study, and it will be a between groups design, which is why we're doing an independent measures t-test, because each group will have its own mean, and those means are being compared to one another, as illustrated here in this formula. And our research question will be, is there a significant difference in the DV or outcome variable based on the IV or grouping variable? And you will choose your variables. Your grouping variable has to be a nominal variable where it is categorical in nature. So we need to know what groups or categories we're comparing. And then your dependent variable or your measured outcome variable must be either an interval or ratio data point. And so that is a necessary requirement for a t-test. You will run it through SPSS. I've listed out some instructions for inputting your data and running that analysis for a t-test. Those are written instructions. And then again, just like all your other results, you always need to provide a statement of significance. So there was or was not a significant difference. And then you need to include your statistical evidence. In this case, it will be your t-value with your degrees of freedom and the corresponding p-value and or alpha level. And then a statement of interpretation, so telling us which group scored higher or lower than the other. And you will provide the descriptive statistics for those particular variables. So I actually need to delete this off of here because this is not relevant to a t-test, so I'll get rid of those. But here's a template formula. So there was or was not a significant difference in the DV based on the IV. Make sure you're filling in the blank for what your variables are. Your T, the degrees of freedom, which will be based upon the number of participants that you have. What that value is, and the p-value. Notice the appropriate italicizing of those statistical notations. And then a statement of interpretation. Group A had higher or lower levels of the DV than Group B. And you will include the mean and standard deviation of your measured variable for each group. And so that is what your results will look like. Other than that, there are no other limitations. So your limitation is it's a non-experimental study. It'll be univariate, so there will only be one independent variable creating two groups, not at least two groups only. So you're comparing one measured variable between two groups. And you will have different people in each group. So univariate, a non-experimental univariate between groups design that you will utilize in independent measures t-test for to analyze your data. So other than that, have fun. Choose something that's interesting to you. I'm looking forward to hearing your proposed research questions and letting you all have an opportunity to really serve as the primary researchers and gain an appreciation for what it takes to actually design a study, design the materials, run the study, and run the statistical analyses and present your findings appropriately in an APA paper. Okay, we will connect throughout. Take care.